When you have a quadratic equation in standard form, it's written with a x squared. A is always the number with the x squared. B is the number with x. And C is the number with no x. This is in standard form as long as A is not 0. That's important. Right. If A is 0, then I would have a 0 here. And whatever my number is for x and whatever my number is for c, and my equation would no longer be quadratic if I took this part out because I multiplied times 0. I would have a linear equation. So anytime that there's an a missing, we know that a is not 0. It can be absolutely any other number. So when I don't have an a, then a must be 1. We'll calculate the axis of symmetry using the b value and also the a value. And the axis of symmetry for a quadratic, let's say it's over here, I'll have a vertex on the axis of symmetry somewhere. And then I'll have a curve like this. The x part from my vertex will be the x that I use from the axis of symmetry. And then when I find y for this x, then I can plot my vertex. A works like slope as long as you are very close to the vertex. So note, A is like slope. Only in a very specific circumstance, and that is when you move one block right from the vertex. So it's not like slope very long. But you can use that information to find additional points to graph. Anytime A is positive, bigger than 0, then your graph will open up. And if A is negative, less than 0, your graph will open down. The y-intercept is at 0c, and this is something that you can just remember if you're a remember little odds and ends of things person. And if you'd rather not have different little tricks and things to remember, we can sort out where the y-intercept is. Without this, it will turn out to be at 0c. The reason is when I have, well, the y-intercept happens at the y-axis. And at the y-axis, x is 0. So if I substitute 0 for x in my equation, so I'll have a, and then I'll substitute for x, and I square that, and then I add b, whatever that is, and an x that I don't square, and then I add c. If I put zeros where the x's are, then a number times 0 squared is just 0. And a number times 0 again is 0. And all that's left when x is 0 for that point is that y would have to be c. So that's where this comes from. With this example, I'll find all the things that we'll need so that we can graph. I need to identify A, B, and C because I use those values for different things. With this example, there's no A. And whenever there is not an A value, A is 1. If there's no B value and there's no C value, that's different. So if I don't have a B, then B is 0. If I don't have a C, then C is 0. But a missing A, we had a rule that A cannot ever be 0. So a missing A means A is 1. So for this equation, A is 1, B is 4, B is the number that goes with X, C is the number with no X, so it's 3. I'll need A and B so that I can calculate the axis of symmetry. I have a formula, X equals negative B, so whatever B is, I'll change the sign. B is 4. And then I divide this by 2 times A, and A is 1. So X is equal to negative 4 over 2. The equation for my axis of symmetry is X equals negative 2 when I reduce this fraction. So now I have a vertical line equation for my axis of symmetry, and my vertex will be on the axis of symmetry, so I've also found the X part of my vertex. I need to find the Y part of the vertex, so I substitute into my equation that I'm trying to graph. Here, it was x squared plus 4x plus 3. I take the x's out and make a space to substitute. And in those spaces, I'm going to choose that x is negative 2. And then I can calculate this. Y will be 1 times negative 2 times negative 2. When you square a number, you multiply it times itself 2 times. And then I have 4 times negative 2. It's negative 8. Then I have plus 3. 1 times negative 2 is negative 2, times negative 2 again is 4. So I have 4 minus 8 plus 3. That's negative 1. So when x is negative 2, y is negative 1. Let's look at one that we can graph. For this equation, I'll identify A, B, and C first. A is 1, B is 2, C is also 2. My y-intercept is where x is 0. So if I take the x off here, and I also take it off here, then I get when x is 0, y is 2. And I can plot that point. My axis of symmetry is found by using the formula x equals negative b divided by 2a. And I'll substitute b, which is 2, and a, which is 1, into this equation. So x will be equal to negative 2 over 2. My axis of symmetry is at x equals negative 1. I have a vertical line. That crosses the x-axis, where x is -1. This is my axis of symmetry. Since a is a positive number, my graph opens up. We'll continue graphing, and then we'll be able to answer this as well from looking at a picture. I calculated the axis of symmetry. My vertex is on this axis of symmetry, so for my vertex, I know that x is -1. I just don't know what the y is when x is -1. To find the value for y, I substitute into my equation this x squared plus 2x plus 2. I'll take the x out and make a space to substitute. So I have something squared plus 2 times same value plus 2. In each of those spaces, I will put -1. That's the x for my vertex. So y is equal to -1 times itself twice. -2 plus 2. -2 plus 2 are inverse of each other. So those zero out, and I just get y equals -1 times -1. That's 1. So when x is -1, y is +1. And I can plot that point. I need another point to be able to define this curve. So I'm going to pick, well, you can pick where x is ½ I already found the point when x is 0, that's right here, y is 2. I could choose x is half. Any of these would work. I'm going to choose, though, where x is 1, and I'll find the y for this x value so that I can plot another point and define my curve. And again, you can choose any point. I recommend choosing one that's close to the vertex because this graph will grow vertically much more quickly than it does horizontally. So choose one that's close nearby. Again, I'm using x is 1. So there will be a point, 1, I'm not sure yet, that I can plot here. To determine what the y is there, I substitute into my given equation that I'm graphing. Everywhere there's an x. So I set this up to substitute, and my x is 1. That's the x I chose. So I have 1 squared plus 2 times 1 plus 2 again. That's 5. So when x is 1, y is 5. Here. And now I can draw in the curve. This green line, this vertical line, is my axis of symmetry. So I know that there's a reflection on the left side that matches this curve on the right side. If I go one step out to the right, I went one step up, so I can go left 1, up 1. There's my reflected point. From the vertex, if I step 2 to the right, I step up 1, 2, 3, 4. So if I go 2 left, I also go up 1, 2, 3, 4 right here. And I can draw the reflection to complete my parabola. The domain of this graph, I need to check my edges here. I have arrows. So my smallest x, this arrow goes left and also up. Negative infinity is the left. Positive infinity is the up. So my smallest x is negative infinity. And my other boundary is also an arrow, goes to positive infinity to the right, and also positive infinity vertically. The range at my vertex I have either the highest or the lowest point. This one opens up. So I have a lowest. My range describes the y's from lowest to highest. So my graph is drawn from 1 to infinity. And at 1, I put a square bracket because this is a solid line. It's an equation. It's not an inequality. There's not a hole here. And I have a solid line, so this is closed. Here's another example to graph. I'll start by identifying A, B, and C. A is -2 for this equation. B is -8. C is -12. My y-intercept is at 0, C, so 0, -12. My axis of symmetry is found by solving this equation, x equals -b, so I'll put a -8 in here, divided by 2 times a, and a is -2. -8 is 8. 2 times -2 is -4. This can be reduced. X is equal to -2. This is my axis of symmetry, a vertical line marked where x is -2. From here, I need to determine the vertex. So I use the h from the axis of symmetry that I just found. And I need to calculate y when x is -2. So I will write my formula or my equation that I'm graphing. Y equals -2. I'll take the x's out and make spaces to substitute. When you write this equation, be really sure that this gets squared here. That's a common error, is that students forget to square that first x. That is what gives us a parabola shape. So make sure this one gets squared. I'll substitute -2 for x in each of these spaces. And when I calculate, I have -2 times -2 times -2. That's -8. And then I have -8 times -2. So that's +16. And then there's a -12 here. When I combine these, I find that when x is -2, y is -4. And I can plot that point. This is my vertex. I can use A like slope one step away from the vertex. One step to the right of the vertex. So I can go right 1. Well, it's -2/1. So I would go down 2 and right 1. And I'm using A to find this point. Now I have 2 points to the right of my vertex, so I can draw in the curve. I could also choose a value for x somewhere here on the same side where I have my y-intercept and substitute and calculate, just like I did with the vertex. I could substitute a value for the x I choose and calculate what y is so that I can plot a point. This is reflected across the axis of symmetry. So the rest of my curve looks like this. And then I describe domain and range. Domain, we're quadratics that open up and down is negative infinity, infinity. Range, this one I have there's a top. There's a highest at the vertex. And I always describe range lowest to highest. Lowest is negative infinity. The highest is -4. I have another example for you to work. I want you to try this one. So please pause your video and try to work through this the same way we've been going through. Find the y-intercept, axis of symmetry. Use that to find the vertex. Vertex is calculated. Find another point on the same side of the vertex as where the y-intercept is. Determine whether your graph opens up or down, and describe the domain and range in interval notation. Please check your work as compared to this example. Let me know if you have any questions. Also, I want to share with you the steps in general for how to solve these. I have it printed out. So these are the things we did in order to graph a quadratic equation that's written in standard form. Then additionally, we described domain and range and interval notation.